The first thing that we will determine about our new MDL material here are the basics of how it will process any reflection and lighting data that it receives. To do this, we need to set up a BSDF. BSDF standing for Bidirectional Scattering Distribution Function, which, although sounding like quite a mouthful, is simply a function that decides how light and reflections are scattered across the surface of geometry. Now, it should be noted that this is usually split into two operations and has initialisms that you may be more familiar with if you come from using materials in DCC applications, such as Houdini and 3ds Max. These two operations being reflectance and transmittance, so BRDF and BTDF. In this instance though, our BSDF node will, in simple terms, combine the two functions we just mentioned and use the incoming and outgoing light angles in order to decide how light on an object's surface should be scattered. Let's create our BSDF by firstly making sure that we have nothing selected in the graph, and then by pressing the spacebar key and typing the words GGX into the search box. We will use the Smith model for our BSDF, and so all we need to do is click to select that, and it gets added to the graph. The Smith model uses a volume scattering approach to light distribution as opposed to a surface scattering approach, which in simple terms can help us create more complex materials. If we place our cursor over the node, we see that the input names appear. We will of course need to make sure that we are zoomed in close enough in order to read them. But we have U and V float values for our roughness, we have a tint color, which we need as we are creating a metal, and we have a tangent U and scatter mode. To keep things moving along, let's see how our GGX node will affect our material. Although, if we try piping this into our material output, what we get is a single red dotted line, meaning we cannot connect the two together. To make this work, what we need to do is run the GGX node through a material surface node. And so, let's delete our connection, drag out from the blue square on the BSDF node, and then type the word surface. We can then click to add the material surface node, and hook its output up to the material surface input on the material output node. What we see now are the basics of a surface material taking shape. Let's set up a colour for our metal next, as any artist using this shader will probably want control over the tint colour of the metal. To do this, we can left click and drag from the tint or colour port on the BSDF node, and then from the top of the list select the colour option. And if this doesn't show up, we can simply type the word colour to shorten the list that we are seeing. Let's now see how we can expose parameters in an MDL graph, which we can do via a right click on the colour node, and then clicking the exposed option from the list. As soon as we do this, we get to fill in some information so that any artist using the material will know what each of the exposed parameters is supposed to do. Let's give the parameter a name, so tint_color, which we can set to be the display name as well. And then we can place this node inside a group called surface by typing the word surface inside the in-group section. In the description, we can type tints the surface color. If we double click in some empty space on the graph, and then scroll down, we can see our setup work. And if we hover the mouse over the tint color heading, we get our description pop up as a tooltip. If we change the color then to say a gold, so float values of 0.9, 0.65, and 0.09 in the RGB controls, we can see the material update accordingly. Now that we have the basics set up and have our material displaying in the 3D view, time in the next video to give our metal some anisotropic highlights that the user can control.